Hello Year 12 and welcome to this video here on comparing samples and populations. How exciting. Now there is a little bit of a blurb here at the top that tells us that there are different symbols and slightly different sort of meanings for the mean of a sample or a population. Look, it's nice to know that that exists, but we are going to use this X bar whether it's for a population mean or a sample mean. Okay, we might not be using it perfectly correctly. X bar for mean, and we're just going to call it the mean. Okay, that's all it is. One way or the other, we are going to be finding the mean of the population, and we're going to call it an X bar. So, let's have a look here. I have a population of 5. Find the mean of the population. I add all those up. 2 plus 4 is 6, plus 6 is 12, plus 8 is 20, divided by the number of things there. Well, I'm not going to use them here. X bar equals 5. No, 20 divided by 5 is 4. Right, the mean is 4. List all populations of varying sizes from 1 to 5. N equals 1 to N equals 5, right? That means the groups of 1, that's 0, 2, 4, 6, and 8. The 2s, that's 0, 2, 0, 4, 0, 6, 0, 8. 2, 4, 2, 6, 2, 4, 2, 6, 2, 8, 4, 6. There's quite a lot of them. How many are there? I reckon there's probably 31. Have a look! Look, here's a spreadsheet that I made and copied over here. Okay, so these are N equals 1, this is N equals 2, N equals 3, N equals 4 and N equals 5. Notice a bit of symmetry here between, say, N equals 2 and N equals 3. Because if you are choosing 2 of those 5, you are leaving 3 out. Right? Every one of these groups here will have a pair with, so if I've got a group with 0 and 2, there must be another group with the other ones, 4, 6 and 8. 4, 6 and 8, right? 0 and 4, right? And in fact, they're sort of working from the top down, from the bottom up here. They're going to match up. Same here. If I choose 1, I leave 4 out. If I choose 4, I leave 1 out. So I could say that this is the group that doesn't include 8. This is the group that doesn't include 6, and so on. Right, so we do get a certain amount of balance, of symmetry with these. If you have to list them all, it's not a very fun thing to have to do because it takes a while. You need a good system so you don't miss anything. Right. Anyhow, so there are all 31 possible samples that could be taken. Now it asks us then to list them all. Yeah, well, they're listed. Here it says, find the mean of each of these samples. So the mean of 0, okay. So that's why I used a spreadsheet, because 1, there's a lot of them, and 2, Excel will work all those things out for me nice and neatly. So there's the mean of every one of those groups. Which group has the biggest mean? Well, unsurprisingly, it's this one that just has 8 in it, and the smallest have got a mean of 0. You'll see there are quite a lot of 4s in amongst them. Hardly surprising. Find the mean of the sample mean. Okay, so I add all 31 of those means together and divide them by 31, and I get this here, mean of the means is 4. How does it compare? It is the same. Okay, the mean of the mean of all possible samples is equal to the mean of the population. Don't try to work that out by listing all 31 samples, by calculating all of the means, as we did just there, and then doing that, because it's so easy to make a mistake. And it's so time consuming when you just need to remember the mean of the means of all possible samples is equal to the mean of the population. Wonderful. There you go. Rightio. Well, that's it for comparing samples and populations. Not super exciting, to be honest. You can do all of this stuff here, really. If you get a question on this, it's going to be what is the mean of the mean of all possible samples, and you say the mean of the mean of all possible samples is equal to the mean of the population, and you calculate the mean of the whole lot, and there you go. It's all done. That's the way to do it. Okay, enjoy.